Yes, we can't hear you, Batu. You are breaking. Can you repeat what you said?
About the formula.
Hmm?
Can
You said the formula?
Yes, the formula, like, can you say F3 equal PV bracket of R close?
To be honest, I'm not hearing you. I'm not hearing you clearly. I'm not hearing you clearly. I'm not hearing you clearly. Okay, maybe you can try when your network is fine. Okay, for now, do we have any question before we move to discounting? Before we move to discounting, we're going to do discounting, and then we're going to look at NPV analysis. Just one little question. Then when we come on Tuesday, we're going to do an exam type NPV analysis question, and then we do IRR, and then that will be the end of the class for this semester. Okay. Any question, please? Any suggestions before we move? So this is the way we do our compounding. This is the way we calculate our future value or our terminal value. Is that clear, everybody?
Hello?
Yes. Okay, we are moving. So we're going to go to another technique called discounting. Okay? Another technique called discounting. This is on page 8 of your handouts. Page 8 of your handouts. So discounting is the very opposite of compounding. Okay? Discounting is the very opposite of compounding. Okay? So if you compound, that means you have a present value, you want to find a future value. Therefore, if you're going to discount, you must have what? A future value which you want to bring to present value. So that's exactly. And we use the same formula and how to call it, derive our discounting formula from it. So what I'm going to do is I'm going to duplicate this worksheet. This worksheet is called terminal value. I'm going to duplicate it since I will need some details here. Okay. So I'm going to duplicate it. To duplicate it, we click on this little drop-down menu and we say duplicate. Okay. If we duplicate, it's going to say copy of terminal value. Now we're going to change this to present value. Okay, so we're going to double click this and call it present value instead of terminal value. Okay, we're going to call it present value. Are you following, class? So this worksheet here and this are the same because I've duplicated it, but I'm going to make amendments here. Okay, so present value, I'm going to double click on this, then I copy so I can use the same title here. I paste. Okay, now what we need for now is only the formula. This is a question that we have done previously, so I'm going to delete this. Now, what we need is the formula. Okay, so this formula here is the formula for terminal value. Now, the formula we want for our present value will be what? It will just be from this formula. So how can we derive our present value formula from here? Who can help? Where are the mathematicians?
Huh?
So where are the mathematicians? How could we make our discounting formula from our compounding formula?
Huh?
Let's see.
Yes. Hello?
Huh?
Yes.
I think it should be x
Value.
equals to v into 1 plus r over n.
It should be x equals to
V
mm,
into bracket open 1 plus
so you mean let me write, you say it's going to be x equals
v, the value,
v
bracket open
bracket open
1 plus the rate
1 plus r
bracket close
bracket close
to the power n.
raised to power n.
That's what I think.
Is this correct, class?
That's what I think.
Hello? Hello?
That's what you think, yes.
So,
Is this correct? Yes.
No, it's not.
No, it's not correct. It's not. It's not correct.
It's not correct. No.
Okay, what is correct then?
It's not correct. No.
What is correct?
There's
We're going to
divide both sides by
One after the other, please. One after the other. Basin, you want to try? Basin, please. Basin? Hello? Are you with us, Basin? You want to try?
Hello?
Yes,
Yes.
Governor.
Yeah, you want to try, Aja?
We're going to divide both sides by the 1 plus r raised to the power n. So
Okay.
it's going to cancel out each other, and we're going to left with
Okay.
x equals v over 1 plus r raised to the power n.
Good, excellent. So in other words, what are we doing? What are we doing? What is his mathematical name? Change of subject in an equation, isn't it? We are trying to make x the subject of the formula.
The subject of the formula, yes.
Yeah, so it's what we call change of subject. Okay? I did modern maths, you know. Maths is so important. Okay, so we're saying that the present value, which in this case is x, okay, is equals to v divided by 1 plus r raised to power n. The reason is for terminal value, it is what? V is equals to x into 1 plus r raised to power n. So now we're going to make x the subject of the formula, just like Basin explained. Okay, so you could equally say v is equals to x, that you could also put it the other way around also, x into 1 plus r raised to power n equals to v. Then you could say x is equals to, okay, v, okay, and the 1 plus r raised to power, their position is going to change. So if their position is going to change, their sign will also change. Their sign at the moment is x multiplied by, so instead of multiplication, the opposite of multiplication will be division. So you'll have x is equals to v divided by 1 plus r raised to power n. That one, unfortunately, you have to know your maths to be able to do that. Okay, that's a simple change of subject in maths. I've learned it so many years ago, but I think I can still remember it. So that's what you do. Okay, but if you don't know how to do that, then you just have to memorize the formula. But it's not something big. You can easily do it. Okay, so like I said, discounting is a situation whereby we have a feature value. We want to bring it down to today's value. Okay, the reason why we want to do that is when we have an investment, the investment will relate to the feature. That means your cash will be injected now, but any revenue that you anticipate to get will flow in the future. And also there will be some costs also that will be incurred in the future. So in order for you to do any meaningful decision, in order for you to take any meaningful decision now, those future cash flows will have to bring them, you'll have to bring them down to today's value. We all know money tomorrow, money in years' time, values less than money now. So those investments, those inflows to the investments, tomorrow, if for example they are 10,000, they will worth less than 10,000 now. So you have to discount them to today's value and then compare the ins and the outs so that you can be able to know whether your bottom line will be great, so you can take a decision or not to take any decision. Okay, so that's the essence of discounting. Good. So let's look at this example on page 8, I guess. On page 8. So it says, if a company expects to earn a compound rate of 10% on its investments, how much will it need to invest now to have the following investments? Okay, so 11,000 after 1 year, 12,100 after 2 years, 13,310 after 3 years. You see, these were the numbers that we looked at. So which amount was invested? The amount that was invested was 10,000, wasn't it? So if you use your formula, you'll be able to get 10,000 immediately. So that means what you do is you take your 11,000, use your calculator, please. Take your 11,000, which is your V. The 11,000 is your V, okay? Divided by your 1 plus R. The R here is how much? It's 10%. So R is 0.1. So 1 plus 0.1, which is 1.1. Okay, and then this time is going to be raised to power, since it's year 1, is going to be raised to power 1. And any number raised to power 1 is the number, isn't it? Okay, so if you take 11,000 divided by 1.1, how much did that give you?
10,000.
10,000, okay. So after 2 years also, take 12,100 divided by your 1 plus R raised to power n. If you divide it by 1 plus R, that will be 1.1 raised to power 2. So do that. 12,100 divided by 1.1 raised to power 2. How much is that?
10,000.
10,000, excellent. So do the same thing, 13,310 divided by 1.1 raised to power 3. Okay, is that clear, everybody? So that's the way you do your discounting. Okay, but like I said, as accountants, we like to simplify things. We like to simplify things. So as such, instead of keep dividing, we have devised a formula whereby we multiply, we find a discount factor and we multiply it by the future value to get our present value. Okay, so that's what we call discounting using a discount factor. Okay, so I'm going to look at that. So using a discount factor. Using a discount factor. Okay, so that one also, they derive this discount factor thing from this formula. You know, when we looked at this formula, we said for the second year, it's going to be what? It's going to be what? 12,100 equals, bracket opens, 12,100, isn't it? We said 12,100 what? Divided by
1.1 raised to the power 2.
1.1 bracket closes raised to power 2, isn't it?
Yes.
Okay, we close the bracket again. Okay, 12,100 divided by 1.1 raised to power 2. No, this cannot be correct. Let me just do that again. Equals 12,100. Okay, divided by 1.1 raised to power 2. So that gave us 10,000. This is what we did, yeah? This is what we did. But if you do this, you know that equally, you could say, so let me just show the formula. Let me show the formula. I just want to show you how they arrive at the discount factor. Okay. You know, this is what we have, 12,100. Can you see this here? Can you see it?
Yes.
Yes.
Okay. So we had 12,100, which is what? 12,100 is the V, which is the future value. We say divided by 1.1. 1.1 is what we have in the bracket here, raised to power 2. Is this not equal to 12,100? Okay, is this not equal to 12,100 multiplied by 1 divided by 1.1 raised to power 2? Is it not the same? This and this, mathematically, are they not the same? 12,100 divided by 1.1 raised to power 2 is the same as 12,000, okay, multiplied by, sorry, this should be multiplied by 1.1. I've got too many points there. Okay, multiplied by, sorry, 1 divided by 1.1 raised to power 2. Put it in your calculator and see whether it's not going to give you the same answer. Is it not the same? Is it not the same, class? Is it not the same?
Yes, it gave me the same answer.
The same.
Yes.
Try it, the others also. Try it. It's the same, yeah? For those of you who have tried. It's the same. So, yes. So this is what I'm going to use. Okay. But accountants have derived this so that this first part will be what? This will always be our feature value, and we're going to multiply by 1 over 1.1 raised to power 2. So this 1 over 1.1 raised to power 2 is what we call our discount factor. Okay? So this here is what we call our discount factor. So that if you have your 1 divided by 1.1 raised to power 2, 1 divided by 1.1 raised to power 35, that will always be your discount factor, and you just multiply by your feature value. Is that not easier? Is that not easier?
Yes.
Yes, that's a lot more easier. Okay, so that's why when you look at 4.2.1, the question that is there is exactly what it has done. So let's just do that. So this is very, very important. I just want to show you how they arrive at this concept of discount factor. Okay, because what we do as accountants, we don't go and say 12,100 divided by 1.1 raised to power 2, 13,000, this, that, divide by 1.1 raised to power. No, but we take the future value and we multiply it by the discount factor. So you have to calculate your discount factor. Okay, is it clear now? Okay, so let's look at this example, the one we just did. We're going to do it using a discount factor. Okay, we're going to use it using a discount factor. Okay, so we'll have here, we will have feature value, okay, which is V. Let's say feature value. Okay, I'll just say feature value. So we have here feature value. You will have your discount factor. We just sort in DF, and the discount factor is on 10%, isn't it? Discount factor 10%. And then we have our present value. I just sorted it as PV. Okay, so year 1, year 2. So I'm going to use the 2 and drag it to get my 3, and then I'll align it to the center. Okay, so what's the feature value for year 1?
11,000.
11,000. Excellent. Year 2?
12,100.
12,100. Year 3?
13,310.
13,310. Okay, so we're going to make this we're going to number format it. We're going to use the financial, but at no DP. Okay, so that's the feature value. Now, we have to find our 10% discount factor. So how do you arrive at your discount factor? We have seen it in this formula here. We agreed that this part here is the discount factor. Is that clear, everybody? Are we together?
Yes.
Yes, sir.
Yeah.
Okay, right. Just want to draw a line on this one. Okay, well, anyway, you're going to, let me just color code it so that you know the difference. Okay, so this will be the discount factor. Okay, so you see, this one in red is the discount factor. So how do we arrive at the discount factor for the first year? Give me the formula.
Equals to
Equals
C18.
C18. No, We are calculating only the discount factor.
Oh, okay, okay.
The discount factor, the formula is here, is in red, this one. Okay, so how to call it, the 1 is the 1 year. So 1 divided by 1.1 raised to power 1 will be year 1, raised to power 2 will be year 2, and so on and so forth. So for year 1, we're going to say equals 1 divided by
1.1.
1, raised to power
1.
Raised to power 1. Okay, so discount factor also, take note, if you have not been told, always take it to 3 decimal place. Always take it to 3 decimal place. Okay, so you can just copy here, but then you have to change the years. In fact, what you could do is, instead of raised to power, type in raised to power 1, you could use it here. We enter, then we just run down the formula. Okay, correct. Can you see? So it's going to be 1 divided by 1.1 raised to power 1 for year 1, 2 for year 2, and 3 for year 3, like that. So these are your discount factors for 10%. Usually in exams, when you go to do maybe your ACC or your masters, they usually give you discount factors when you're doing some advanced forms of NPV analysis. Okay, but for now you have to calculate it. Okay, for now you have to calculate it. Okay, so now what will be our present value then? What will be our present value?
It's going to be C18 multiplied by D18.
Okay, it will be C18, which is our feature value multiplied by D18, which is our discount factor. Okay, and we replicate. Can you see? Excellent. So I'm going to use this. Is this clear?
It is.
So it's all from here. From this formula, this is the PV multiplied by our discount factor. This is our discount factor, and we have our present value. So in other words, if you have money in the future, it's worthless now. This is in 1 year, but at the moment it's only 10,000. If you have 12,100 in 2 years, it's only 10,000 now. 13,310 in 3 years, at the moment is only 10,000. Time value of money. Okay. Okay, so let's look at interactive question 2. Interactive question 2, and then we will do our NPV, just the first question of NPV, and we'll call it. Then Tuesday, we're going to do exam type question, which is a big one. It was a past ACCA paper we're going to look at, and if you're going to have any investment appraisal question in exams, it's going to look like that. So please make sure you are present on Tuesday. That class is very, very, very important. The question we are going to work will be a type of question that you expect in exams. Things like this can only help you to understand, but you cannot have things like this in exams. They are for babies, yeah? They are really for babies. Okay, so let's turn to page 9. On top of page 9, interactive question 2. Let's do this question now quickly. Can you do it on your own quickly? Spender expects the cash inflow from an investment to be 40,000 after 2 years and another 30,000 after 3 years. Its target rate of return is 12%. Use the table below to calculate the present value of these future returns. So you have your year. So the years will be 2 and 3, isn't it? The cash flows will be what? 40 for year 2 and 30 for year 3. Then your discount factor will be at 12%. So you need to calculate your discount factor at 12%. And then you multiply your cash flow, that's your future cash flow multiplied by your discount factor to give you your present value. Quickly, everybody. Are you with me? Hello?
Yes.
Yes. We need to follow the protocols. The way the table is, we need to lay it down. Okay. Don't worry. So long as it's not exam time, we can always do it together, but in exam time, we will not be able to do it together. Okay, so let's do it together quickly. Please pay attention. So it's for Spender Limited, yeah? Spender Ltd. Okay, it's for Spender Limited. So let's do our layout as given in the question. So we have year, we have cash flow, we have year, we have cash flow, we have our, let's just make it short. Let's say DF for discount factor 12%. Let's say DF 12% to make it short. And we have our PV. We can use PV for present value. In exams, you can use this kind of abbreviations. No problem. Okay, you can use DF for discount factor and PV for present value. Okay, so we have here what? 2 and 3, isn't it? Okay?
Yes.
Okay, so give me the cash flows, please. For year 2, what's the cash flow?
40,000.
40,000. And year 3, what's the cash flow?
30,000.
30,000. Okay, so now we need to calculate our DF, our discount factor for 12%. Okay? Who can give me the formula for that?
It's going to be 1 over 1.2.
Right, so it's going to be equals 1 divided by
1.12.
1.12.
12.
After point, you don't say the number like that. 1.12.
1.12. 1.12, sorry.
Okay, 1 divided by 1.12.
Raised to the power D26.
Raised to power D26. Thank you. We enter. And we accept that. So we use our 3DP formula. So our 3DP format, we just use that here. So correct. So it's 0.797, 0.712. Is that clear, everybody? Are you following? Please, this is a must. And I bet you discounting will come in the exam. Okay, so please take note of it. It's very, 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 very important. You cannot do DCF techniques. That's why they call them DCF techniques, because of the discounted cash flow techniques. You cannot do them without knowing left, right, center how to do your discounting. Okay? Very, very important.
Mr. Foreman,
Yes.
the question is on page 9, right?
Yes, on top of page 9. Spender. It says spend. It says interactive question 2. Present value calculation. Difficulty level intermediate. Have you seen it? Have you seen it? Okay, we're going to move. So now, what next do we do? What next do we do? Let me see who. Lamin Jawara, you've been quiet today. What do we do next? Jawara? Lamin? Madeline?
Yes, Mr. Buvan.
Are you following,
Hello.
Madeline? Yes, Madeline, are you following?
Hello, Mr. Fufana.
Yes, Madeline.
Hello.
Yes, we're hearing you loud and clear. What next do we do to calculate our present value? What do we do next to calculate our present value? She's not hearing me. Okay, who can help?
Yes, sir.
Yes, go ahead.
We're
Equals
going to multiply the cash flow with the discount factor.
Sorry?
We're going to multiply the cash flow with the discount factor.
With the discount factor. Excellent. So give me the formula. Equals
C25, C26, sir.
C26 multiplied by
D26.
D26. Enter. Excellent. So we can round them up to, okay, correct. Okay, all right. So easily, this is the way we do our discounting. Now, this will nicely take us to NPV analysis. So NPV analysis, otherwise called net present value analysis, is simply the difference between the discounted cash inflows and discounted cash outflows. So that means your cash flow, okay, when you calculate all your cash flows, both ins and outs, the difference between the ins and outs is your net present value. Okay, very, very, very important in investment appraisal. In fact, it is the most important appraisal technique that is commonly used. Okay, and the main reason why it's the most important is because it takes time value of money into account. Here, it takes time value of money into account by using the discounting technique, the one we've just done now. Okay? So it's simply that. So, and using the NPV method, decision is based on the following. Okay? In other words, if we are asked to calculate, if we are asked to appraise a project using an NPV method, our conclusion we're going to recommend to the managers of the project or to the company will be as follows. One, if the calculated NPV is a positive one based on finances, we should advise that the project should be executed. Two, if the calculated NPV is negative, we should advise that the project does not go ahead. because if it goes ahead, it might not be profitable. 3, if the calculated NPV is 0, okay, that means the net present value of inflows and outflows are the same, we advise that the project is not executed as well. Okay, the reason is these are all forecasting. There might be some inherent risk that might not be imminent. Okay, there might be inherent risk in the future that could turn the 0 stage to a loss stage. Okay, so it's really, really important that you know these 3 different advices. Okay, so having known that, I think we can definitely stop here. I'm going to give you a little assignment. That's this NPV on Slugger Limited. So you do that. It's a little one, so don't complain that we already have an assignment for. So do Slugger Limited, okay? There is nothing difficult in it. The first one is an outflow, which is 100,000, and year 1 to year 4 are all inflows. So at year 0, do you usually discount it? If you have a cash flow, whether inflow or outflow at year 0, do you discount it? Do you discount it?
No.
Hmm?
No, you don't.
We don't discount it, exactly. Why? Why we don't discount it? Because it's simple. The reason why we are discounting, we want to bring all future cash flows into today's value. So if it is already in today's value, why discount? Okay, so use the same format like we have done here, and put the first one as year 0, okay, and that will be an outflow. The rest will be inflows. So discount all the inflows, add them together, and knock them off from the outflow. That will give you your NPV. Okay. So I'm going to put on top here NPV assignment. And so some students are going to start hating me. What's wrong with this, Mr. Fofel? Every day assignment. Well, this is a core paper. I really want you to understand it. I really want you to understand. Even if you get a C plus or a B plus or whatever grade, but when you go out there, I really want you to be a very, very, very good management accountant. That's all. That's why I'm taking all this risk. I could have used the same system as the other lecturers. Come, go your way. I give you simple exam, and I give everybody A or A plus or B. That is not going to benefit you. To be honest, it's not going to benefit you. Accountancy is a dynamic profession. You have to do it, and it, of course, keeps changing. So if you don't have a solid background, if you go out there to practice, you'll find it very, very difficult. So that's why I'm taking all this trouble. Okay? So please, you need to understand that. Not that I want to make life difficult for you. Is that clear, everybody? Is that clear? Am I making sense?
Yes.
NPV analysis.
Yes, sir. You're talking.
Yes. RODER. Okay. Page 9 of the handout. Yeah, I want us to have an early close because tomorrow I'm having some Excel training with some UTG students. I think it's the debate society also. So I need to rest. NPV assignment, Slugger. Page 9 of your chart. Are you aware of that training? Are you aware of that? Hello? Are you aware of that training?
Yes, yes.
You are aware?
Yes.
Okay. Are you coming there? It's all organized by the Debate Society, not me. Actually, they have already identified the first 40 students, so I think it's full now. So if you have not got yourself there before, no chance, maybe until next time. Okay. So this is it. So this is the assignment. Let's do it. It's a very, very simple one, just very similar to what we have done. The only thing is you have to knock off the inflows from the outflows to arrive at your NPV. That's all you need to do. So include this as part of your main assignment, as part of your main file for your assignment. Okay. Right. So if there are no other questions, shall we call it a day? Any question or observation?
Mr. Bhuvan,
Yes.
this formula that you have written for PV, is it the correct formula? X equals to V into bracket 1 plus R just to the power n.
Sorry?
This formula that you have written for PV.
Sorry, 1 second. Let me just do it.
It's 17 hours.
17 hours, yes. We are almost done, so we're fine. Okay, sorry. Can you repeat? Can you say it again? What did you say?
This formula that you have written for PV.
Okay, this formula, where is the formula?
No. Go back to the previous.
Okay, this formula for the present value, yes.
Yes. Is it the correct formula?
Is it the
correct formula?
Yes, it's the correct formula, yes.
Okay. I just wanted to confirm. Thank you.
Yes.
All right.
Yes, we've gone through it. It's x is equal, x of course is what? The present value, okay, which we are looking for, is equals to v, which is the feature value, okay, divided by 1 plus r raised to power n. But what we're saying, instead of using this all the time, we were able to derive formula whereby we only need to calculate, we only need to take our feature value, multiply by our discount factor. This is why I derived this formula from this, function from this formula. Is that clear?
Okay, yes. I understand now.
You got it. Okay, good.
Thank you.
Okay. So any questions, please? Any clarification before we wrap up? So please, for those of you that are not here today, tell them on Tuesday we have a very, 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 very important class. And of course, it will be our last class, inshallah. Very, very important. What we're coming to do will definitely be part of your exams. There is no doubt about it, inshallah. Okay? So let them attend. Let them attend. Very, very important.
Okay, we will.
Hello, Mr. Fofana.
Yes, Jawad.
Sorry, you were calling me, but I was using two devices. I was working at the same time, so I realized when I try to communicate, then it will be very disturbing, you know?
That's all right. That's all right. You are working where? You mean you're at work?
Yeah, I'm at work, you know. I'm at work, you know. So I'm using the computer at the same time I'm seeing you on my phone. So I realized that is going to create commotion when I try to respond.
All right, that's fine. Well,
And
why
then
why don't you tell your employers that you have to attend class? It's very important that you attend class. Why do you have to be at work?
yeah. Honestly, but today we are very much handicapped, and then my boss told me that I wouldn't be able to have time to stay away from the point, you know.
Okay. Where do you work?
So I work at GT Bank. Yeah.
GT Bank.
Yes.
I know it will be a bank. The banks, they don't
So
joke with
yeah,
themselves.
and then especially this branch at Latrikunda is a very, very busy one, you know.
Okay, you work at the Latrikunda branch.
Sure.
All right. Okay. Fine. Okay, no problem. Just try to catch up. The videos
Yeah.
will be
Sent to the page.
uploaded.
Okay. Yeah.
Yeah.
Okay. One thing I also want to confirm with you is like most of the time, if I have to send my assignment, I don't know. I always create a new Excel sheet after I do my assignment there and send it to you. So, but today I hear you say something like put it in your assignment sheet. So I don't know.
No. Your assignment file. I wanted to say your Google Sheet file. You always have to open a new worksheet for a new assignment.
Oh, okay. Because that is what I always do. So
Yes.
I was thinking maybe it's all supposed to be in one Excel sheet. Then we have to create a.
No. Not it all. If you put it in all one Excel sheet, it's gonna be jumbled up. One file, one Google Sheet file. It's not Excel file. We're not dealing with Excel. Please,
No,
if
yeah.
you know you have been doing Excel is not live. Excel is dead.
Google Sheet, I mean.
Except the online one, yeah?
Yeah, Google Sheet, I mean. So every assignment we open new one and then we send. That's what I always do.
New worksheet and you name it and then you how to call it, do whatever you want to do on it, yeah?
Okay, I understand. That's fine. Then I'm on track then. Thank you.
Good, very good.
All right.
Okay, any more observations before we wrap up? Okay, I guess we can stop here. Thank you so much for having me.